we learned about so like I was saying, we learned the first few major differentiation rules. We learned the product rule and the quotient rule. Here we're going to learn a couple more, okay? You've got to keep things straight, and so make sure you're attentive, and let's do this. All right, so in this section we talk about the chain rule, okay? Just a beautiful, beautiful thing, this chain rule, okay? So, okay, previously we learned how to differentiate sine of x, right? What did differentiate mean? Find the derivative. And we learned how to differentiate x squared minus 4, right? So if I have sine of x separately, and if I have x squared minus 4 separately, I know how to take the derivatives of those two. But how about if we combine those two? How about if I now have sine of x squared minus 4? Can I take the derivative of that? So do you see what happened here? Sine of x is my, the parent function, like we used to call back in algebra 2. But now I'm modifying that function. I'm taking a whole other function, x squared minus 4, and I'm putting it inside of the sine. Okay? So if you like, what we used to do back in algebra and pre-calc and stuff is we had f of x, remember? And then we would have g of x, and then we would have to find f of g of x. Do you remember? So I know how to find the derivative of f of x. I know how to find the derivative of g of x. But do I know how to find the derivative of f of g of x when it's a nested compound function? Okay, so do you see how when I have f of x and g of x separately, and then when I put one inside another, I'm sort of like linking them together? And when you have a couple of links, what does that make? A chain, hence the chain rule. Okay? So we're going to take that idea that this is sort of links in a chain, and we're going to take a derivative just like links in a chain. Okay? All right. So the way we take a derivative is the chain rule, which is probably the most widely used differentiation rule in Calc. Okay? All right. So here is what the chain rule says. Okay. All right. So suppose f is differentiable, right? It has to be differentiable for us to be able to differentiate it, period. Okay? Suppose f is differentiable at the point u, and g is differentiable at x. Then the composite function, right, here's what we're talking about. Okay? Here's how the composite function is differentiable. So here's what we do. We take, right, in order to do the derivative of f of g of x, we first find the derivative of f prime, and then we multiply it by the derivative of g prime. Okay? So it's f prime g times g prime x. Okay? F prime of g of x times g prime of x. Okay? Now, okay, so everybody knows who invented calculus? Newton. Okay, so he was the one that got credit for inventing calculus, and yes, he did. At the same time, right, at the same time in a different country, Leibniz was independently coming up with the concepts of calculus. Newton was the one who published it first. He got the credit. But Leibniz also independently found calculus. And so they arrived at the same thing, but because they were working independently of each other, they had different notation. So the way Leibniz wrote it is, if y is f of u, and yes, it's f and u together. Oh my gosh, funny! Let's take a minute. So you know how so we're always talking about, u and v, right? U prime, v prime, and so on and so forth. So if y is f, all right, and u is g of x, then dy dx is dy du times du dx. Okay? How are we actually going to do this? So remember how I said we had a function like this, f of g of x? Okay. We have here an outside function, and we have an inside function, right? So you first have to figure out what is your outside function and what is your inside function. And then when you do that, here's what you do. dy dx is equal to the derivative of the outside function, okay, times the derivative of the inside function. Okay? All right. So let's do this. In the first one or two problems, I'm going to give you, right, how I'm going to tell you how to separate outside from inside, and then after that I won't tell you anymore. All right, so take a look at the function we have here. We have y equals cosine of x squared minus 1. So first you have to identify that this is one where you have a composite function. You have one function inside another. So if you zoom out, what's the outside function? Cosine of x. What's the inside function? X squared minus 1. That's what you have to identify first. Sometimes it's very simple, sometimes not as much. So now, y prime is this. So here's what I do. So you have to figure out a way of bookkeeping. What I do is I put like little check marks. So first you have to take a derivative of the outside function, the cosine. What's the derivative of the cosine? Negative sine. So now this is negative sine. However, the derivative of cosine x is negative sine x. If it was cosine t, the derivative would be negative sine t. If it's cosine of table, the derivative would be negative sine of table. If it's cosine of x squared minus 1, the derivative is negative sine of x squared minus 1. Okay, so now I did the outside. Next, I have to do the inside. Now I have to take a derivative of the inside. And that's just 2x. So when you write it more cleanly, y prime is negative 2x sine x squared minus 1. Okay? And that's taking a derivative with the chain rule. All right? Let's do this one. This is the function. Again, outside function is sine, and inside I have root x. Yeah. Okay. So this is the outer function. This is the inner function. Okay. So y prime is what's cosine root x times, okay, now I have to find the derivative of root x. So here's what we do. Yeah, root x, I always write it as x to the 1/2. And so now the derivative of x to the 1/2 is the half comes down, and it's x to the power of 1/2 minus 1. All right, nobody gets extra credit for not showing any work, for being able to do it all in your head. So if in the beginning you feel like you need to write stuff down, do it. Just get it right, okay? Do whatever you need to do to get the answer right. Right, so it'll be 1/2 x to the minus half, right? So let's put that here, 1/2, what is that? It's 1/2 root x, right? Does that make sense? Yeah. Because, yeah, okay, so it's 1/2 root x. So then y prime is cosine root x over 2 root x, okay? Let's be comfortable with you know, like combining and converging and all that good stuff. All right. Questions? Okay. So let's do this one. An object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by that complicated looking function. All right? Find the velocity of the object as a function of t. Okay, what is it that I have? I have position, right? I need v of t, velocity. What's the relationship? Derivative, right? So v of t is x prime of t, right? It's the first derivative. So now I have cosine of t squared plus 1, all right? Again, identify your outside and your inside function. What's the outer function? Cosine, outer, and then this is your inner. All right, and that's exactly how I do it. So this is equal to the derivative of the outer, well, that's negative sine of stuff, right? T squared plus 1. And then when I take a derivative of that one, either put a check mark on top or cross it off so you don't get confused. So far, we're starting with like the little baby ones. Things get complicated. This is only a 2-link chain. You might have a 3, 4, 5-link chain, okay? Okay, times the derivative of the inside will be 2t. Good. So now, v of t is equal to negative 2t sine t squared plus 1. Okay? Alrighty. Okay. So basically, this is the outside inside. That's exactly what we've been doing. So differentiate the outside function and then evaluate it at the inside function, then multiply the derivative. Yeah.
Just going back, when we take a double, like a second derivative.
Yes. Sorry, wait.
Like later in the chapter, we'll be doing
yes.
of those.
Yes. And now, if you do take a second derivative of this, what rule would you apply? You would apply the product rule. So this would be your u and your v. So you do this one, and then when you're doing this one, that's a chain rule. So you're going to be doing the chain rule within a product rule.
Okay.
Yeah. Yeah. Oh, yeah. Yeah. Okay. dy dx. Okay, so I'm no longer going to, right, you need to identify the outer and the inner function. So tell me. Cosine is the outer and 3x is the inner. So y prime is how much? Is what? Negative sine 3x times, awesome. Fabulous. Okay. Ooh, what about this one? So y prime is what? Cosine x squared plus x times, oh my, look at you guys go. All right. So, and then we always write algebraic functions first, then trig functions. That's like convention. So it would be 2x plus 1 cosine x squared plus x. Okay. So, will we get to repeated use of chain rule? Yeah, we will. That's next. Repeated use of chain rule. This is when things get real. I seriously, like, I know I say this all the time, but I seriously would not mind, like, spending my time doing, like, a sheet of this stuff. Like, I really wouldn't mind that at all. Not at all. Right? Okay. So sometimes you have to use it 2 or more times. And here's an example. d dx of this. Okay? What's the outermost function here? Tangent. So here's what I'm going to do. I'm going to call that number 1. What's the innermost function? What's the, not the innermost. Sorry, I said that wrong. And then once you go in, what function do we have?
5 minus sine 2.
5 minus sine of something. That's number 2. And then is there another inner function?
2t.
The 2t. Okay, so I have tangent on the outside, 5 minus sine on the inside, 2t yet on the inside. So here's how we do this. Okay, this is equal to, first of all, the derivative of the outermost, number 1. The derivative of tangent is secant squared. Good. So it's secant squared of stuff, everything that comes after. 5 minus sine 2t. Okay, done with tangent. Cross it out. Next, it's the parenthesis, 5 minus sine 2t. What's the derivative of that? Negative cosine 2t. Okay, done with that one. Next, times 2. You see that? It wasn't even that big of a deal. So finally, right, we would say, so yeah, the negative here, I'm going to pull it out. So negative 2 secant squared 5 minus sine 2t cosine 2t. Huh? That wasn't bad, was it? Not bad at all. Okay, so what about the power chain rule? Okay, so if you have to take a derivative of something to the power of n. Okay, so the n comes down, and then it's, u to the n minus 1. But then, if this was a function, then you have to take a derivative of that. Okay, so this is where things get a little bit more complicated. So take a look. dy dx, what do we do always when we've got a square root? Make it into, to the power of 1/2. So tangent of 5x to the power of 1/2. Okay, now I'm going to take a derivative. Okay, so is there an outer and an inner function here?
Yeah.
What's the outer function? There is an outer function, tangent. There is even an outer function. Okay, so first it's the 1/2. Let me do it in a different color. So first it's the 1/2. So that comes down. So y prime is equal to 1/2 tangent 5x to the negative 1/2. Then next, it's the tangent. So it's secant squared 5x. And whatever you're done with, take a derivative. Then times 5. Okay? So finally, let's write it all together. This negative 1/2, it's going to come down, right? So in my denominator, I have a 2, and I have a root tangent 5x. And then on top, I have a 5 secant squared 5x. Nice, huh? Okay, should we do one more? Yeah. Okay, so what are we going to do first here? Bring down the 2. So that's number 1. Okay, that comes down. So y prime is 2. 1 plus cosine 2x to the power of just 1. And then what's next? This, right? So that's number 2. What? Negative. Okay, times 2. So that's a negative 4. sine 2x 1 plus cosine 2x.
Is there a reason that sine is before the...
No, it doesn't matter. Just put the 4 first, and then you could have done the parenthesis, then the sign. Okay. All right. Suggestions. Next one. What do we do?
Bring down the 3 and the 4.
3, then 1 and derivative of x3.
Mm-hmm.
And then do the 4.
Mm-hmm. Oh, okay, so we're starting straight with the chain rule.
No.
There is a product rule first. Okay? So here there is a product rule. And then there is a chain rule within that. Okay? So what's u here? U is x cubed, and this is v. So u, x cubed, yeah. And then v, 2x minus 5 to the power of 4. So we're going to do chain rule within the v prime. All right? U prime is just 3x squared. That's easy, right? That's what our biggest problem was before. Here we're going to do chain rule. So v prime, 4 comes down, 2x minus 5 to the power of 3 times 2. And let's simplify that so that v prime is 8, 2x minus 5 to the power of 3. Right, so now y prime, remember, it's going to be uv prime plus u prime v. Right, and remember when you do it this way, then it's like uv prime the diagonal, and then u prime v that diagonal. Okay, so this is going to be x cubed. Well, okay, so we can combine that, right? So it's going to be x cubed times it, well, whatever. Let me just write it. Which two? The inner, the chain rule. So here I did, the 4 came down. Then I had to do the 4 came down, so I got 4x to the, 4 times this to the power of 3. Then I had to take a derivative of the inside. Okay, so it's 8 times 2x minus 5 cubed plus 3x squared 2x minus 5 to the power of 4. Okay, now check out what we're going to do. We can factor some stuff out here. Okay? Here's how we're going to factor stuff out. What can we factor out of here and here? We can factor out a 2x minus 5 cubed. What else can we factor out? What about the x cubed and the x squared? X squared. So we can factor out an x squared and a 2x minus 5 cubed. So what is it that we have left? What do I have left here? I have x times 8, which is 8x, plus here I have a 3 times 2x minus 5. So x squared, 2x minus 5 cubed, 8x plus 6x minus 15. Right. So what do we have here? X squared, 2x minus 5 cubed, 14x minus 15. And that is a calculus problem. Yeah. And that's like nothing. Like later on, that'll be like a part of a word problem. Okay? Yeah. This is it. We've made it. We're there. We're here. We've arrived. Okay? Well, okay. So, at first glance, you look at this and you're like, yeah, quotient rule. Okay. When possible, reduce the number of times you do quotient rule. If there is a way that you could get away with product rule instead of quotient rule, do it. Because what if I wrote this? Well, so what if I did 1 plus 2x to the power of negative 1/2, right? So then I would have y equals x times that, okay? Because what do I have now? Now I have x times 1 over 1 plus 2x, is that right? That's what I have now, that's y. But what if I were to write this like that? Now I can do product rule. Yes, you can do quotient rule. Yes, you get the same answer. Messier though. This is much better. So now I have a u and I have a v. So let's do that. So u is equal to x. V is equal to 1/2. 1 plus 2, not 1/2. I already started taking a derivative. Sorry. V is equal to 1 plus 2x to the negative 1/2. Okay? All right. So what's u prime? 1. That was easy. V prime, negative 1/2. 1 plus 2x to the power of how much? Negative 3 over 2. Okay? Are we done? The chain rule. Times 2 for the inside. But look, that's kind of cool because then these cancel. So this is negative 1 plus 2x to the power of negative 3 over 2. Okay. Y prime is uv prime plus u prime v. Okay, this is x times negative 1 plus, can I put the negative out front? Do you guys mind? Here, negative, and then x times 1 plus 2x to the power of negative 3 over 2 plus 1 plus 2x to the power of negative 1/2. So if you remember in pre-calc honors last year, I had you guys factor this stuff out here. This is why I do that. So let's see what's going to happen here. Okay, so we can factor out a term to the smaller power, right? So here we had something to the power of 3, the same thing to the power of 4. We factored out the one with the smaller exponent. Is that right? Here, which one is the one with the smaller exponent? Is it the negative 3 over 2 or the negative 1/2? The negative 3 over 2, right? Negative 1.5 is further to the left than negative 1/2, right? So we're going to factor out 1 plus 2x to the power of negative 3 over 2. Okay, now look, factoring out is the same as dividing, right? We just never tell you that in algebra or whatever, or you forget that we tell you that, but that's what it is. It's the factoring out is the same as dividing by. Okay, so now let's see what I have left. From this first part, I have a negative x plus, here I have 1 plus 2x to the power of negative 1/2 minus negative 3 over 2. Remember this. So y prime is 1 plus 2x to the power of 3 over 2. Negative x plus 1 plus 2x to the power of how much? 1/2. 1, sorry. Right? Okay, so take a look. You have negative 1 over 2 plus 3 over 2. That's 2 over 2, which is 1. Right? Or 1.5 minus a half is 1. Okay, so finally I have y prime equal to 1 plus 2x to the 3 over 2 times, what do I have here? Negative x plus 2x, huh? Yes. Negative x plus 2x is x plus 1. Okay, this means we don't like negatives, remember? It's x, we don't like negative exponents. It's x plus 1 over 1 plus 2x to the 3 over 2. You can even write this as, oh my, I'm so sorry. Why is this thing open? Oh. I know. Okay, the square root of 1 plus 2x to the power of 3. All right, so the slope derivative of the line tangent, so that's derivative, right? Y prime. Okay, so slope of the line tangent to this curve at the point where x is equal to pi over 3. Okay, I'm given sine to the power of 5x. So far I know the product rule, the quotient rule, the chain rule. Any of those need to be applied here? The chain rule, how? What is the outside, what is the inside? But is it x to the 5th?
Oh, it's 5 sine.
So who does that exponent 5 belong to?
Sine.
The sine. So what if we were to write it not like that, but like this? Is that the same thing? No?
Yes.
Well, yeah, because you bring the 5 to the front.
It is the same thing. So these two are the same exact thing, are they not? If you have sine squared x, it's sine x times sine x. If you have sine to the 5th x, it's sine x to the power of 5. So now, this is the outer function, and then this is the inside function. So y prime is equal to what? 5 comes down, 5 sine x to the power of 4 times cosine x. All right, so y prime is 5 sine to the 4x cosine x. That's more conventional to write. Right, times 1, but we don't write the 1. If it's just an x inside, then we can let it go. Okay, but now we need it at x equals pi over 3. So y prime at pi over 3 is 5 times sine pi over 3 to the power of 4 times cosine pi over 3. Okay, now look. So this is a 5. Here, sine of pi over 3. So between pi over 6 and pi over 3, which one's the bigger angle? Pi over 3, it faces the bigger side. So that's root 3 over 2 to the power of 4. And if that's root 3 over 2, then the cosine of that same thing is 1/2. Okay? So if I go up here, this is y prime at pi over 3 is equal to 5 times. Okay, this exponent of 4 belongs to the root 3 and the 2. Root 3 to the power of 4. Root 3 squared is
3, 9.
That squared is 9 over 2 to the 4th these days, 16. Okay, and we did that without a calculator. Times 1/2. Yes, it is. So this is 45 over 32. What have I found?
slope of tangent line.
The slope of the tangent line. So am I done? Well, what did I need to find?
Finding how to slope.
The slope of the tangent line. I'm done. I'm done for part A. Yay! Because you expect that you need to find the equation of the tangent line, right? If you needed the equation of the tangent line, what would you do?
Plug in x to get y, and then you could
When you say that,
That's it.
when you write out the final answer,
Mm-hmm.
you say y prime
Power of 3.
or can you say m equals?
Either. We use m less and less in calculus. All right. Show that the slope of every line tangent to this curve is positive. Okay, what? I don't know what it's talking about. So let's just divide and conquer. Okay? Divide and conquer. Show that the slope of, tangent to this curve. Okay, I know how to do that. So let's just do that. Let's just find the slope of the tangent line to that curve. That would mean derivative, yes? Okay, so let me just write that in a way that is more pleasing to the eye. Vertical. You guys know how I feel about my... or no, that hasn't come up in this class. I always like to do the fractions like with the horizontal bars like this versus the slash because it gets complicated. Anyhow, so because now if I write it like that, then I could write it yet in a different way, like that. And now it's your basic chain rule problem. Yeah. So y prime is negative 3, 1 minus 2x to the negative 2, right? Yeah? Negative 4, thank you. Just checking. Okay, times what? Times negative 2, thank you. So altogether, this is positive 6 over 1 minus 2x to the power of 4. Okay, okay. Now, okay, so wait, what was that problem asking again? Show that the slope, okay, I found the slope. So show that y prime is always positive.
Limit.
Do we need a limit? Okay, so where is y prime? Here.
Right, it's because the exponent is 4.
There you go. Do you see how, okay, look at this. This is a fraction. What's the numerator of this fraction? Positive 6, right? It's a positive number. The denominator is this. Can this denominator ever be negative? No, because it's whatever you get in here to the power of 4 is positive. Positive over positive is always positive. Okay, so, well, no, so the point is to prove or to illustrate that this is always going to be positive. And so now you say, okay, the numerator is 6 and always positive. Okay, so we established that. The denominator has an exponent of 4, therefore, denominator will always be positive. So take a look at what we have. We now have a fraction. We're now dividing a positive number by a positive number. And when you do that, the result is always what? Positive. Okay, so positive over positive is always positive, right? So let's read the question again. It says, show that the slope of every line tangent to this curve is positive. Well, this represents all of the tangents. And so all of the tangents to that curve are always positive. All right? That's it. That's it. So you can do this for Monday.